My name is Cody, but you can call me Cody. I'm your instructor, here to guide you on your journey to mastering C#. In C#, syntax is the set of rules that defines how your code must be written. It's like grammar for computers. It makes sure your ideas are readable and executable by the system. Every line must follow structure. Statements end with semicolons, code blocks use braces, and names like main and console must use exact casing. Even the smallest error, a missing symbol, a lowercase letter, can crash your code. In short, syntax isn't just structure, it's law. Here is an example of a correct syntax. Using system gives access to system tools like console. Namespace, unlink lesson, groups your code together. Class, program, is your program container. Main is the entry point where the machine begins executing. And console, write line, sends a message to the screen. Never forget the semicolon, one missing mark, and everything fails. Here is an incorrect example of syntax. Syntax error, a semicolon was forgotten. The compiler doesn't guess it needs clear instructions. End your statements properly, or risk a full halt. Here is another incorrect example of syntax. Multiple breaches detected. Program must be capitalized, so must main. And console. C# cares about every letter. This isn't just styling, it's how the system reads your command. That is all for the introduction of C# syntax. In programming, a variable is a named storage, a memory container that holds data while your program runs. In C#, you must declare what type of data a variable holds, like numbers, text, or booleans. The way you name, declare, and use them affects not only how the system behaves, but how well your code can be understood. Let's explore 4 key ways variables work. To create a variable, specify the type and assign it a value. Type variable name equals value. Where type is a C# type, such as int or string, and variable name is the name of the variable, such as x or name. The equal sign is used to assign values to the variable. We have different types of variable. First, we have constant variable. A constant variable is a fixed value that cannot be changed after it's assigned. Use const when you want to protect values from being accidentally altered, like pi or maximum health. In this example, we used const to make the pi unchangeable. Once it's set, it's locked. Here is an incorrect use of constant, where the code declares the const of int max health. Trying to change a constant is not allowed. Once declared, it's frozen, like a rule etched in stone. The second type is display variable. A display variable is a variable used to hold and output information to the user, like player names, scores, or messages. You often combine it with text using concatenation plus operator to show results in the console or UI. For example, in this example, the premiership is value as Ethan. The code then displays the variable to the console. Write line by using plus and adding the variable, flaked or the text to display its value. We can see that player name, Ethan, is now displayed. Here is an example of an incorrect way of display variable. In this code, the user forgot to join the text and variable with a plus. The system doesn't know how to combine them without it. The next type is multiple variables. You can declare multiple variables of the same type in a single line by separating them with commas. It's a shorthand to organize related data like coordinates, scores, or quantities. Here is an example of the correct way to use multiple variables. Declaring multiple int values on one line keeps things clean and easy to read. Now here is an example of an incorrect way to use multiple variable. Forgetting a comma between variables. Without it, the machine thinks it's one broken statement. The last type is identifiers. An identifier is the name you give to a variable. It must follow naming rules. Can't start with a number, can't use special symbols, and should describe its purpose clearly. Good identifiers make your code easy to read and maintain. Clear, meaningful names matter. Player health is a good identifier. It says what it stores. Identifiers can't start with numbers. The system reads left to right, and it expects letters first. That's it. Overall, variables are more than containers. They are the core of logic. Constant values protect your code from accidents. Display variables show your world to the player. Multi-variables organize your logic. Identifiers give meaning to memory. Choose wisely, and your code becomes readable, reliable, and ready to evolve. That is all for the introduction of C# variable. Every piece of data has a specific type. In C#, these data types define what kind of information your variables can store: numbers, text, true, false, and more. Choosing the correct type matters. It tells the system how to process, store, and compare the data. Let's start with int. Int is for whole numbers, no hext, no characters, and no decimals. Just solid values like 1, 2, 3. It stores whole numbers, both positive and negative, without any decimal point. Int memory is 4 bytes, 32 bits. It can also range from -2, 147,483,648 to 2,147,483,647. Best used for counting, loops, indexing, scores, and general-purpose whole numbers. Next is float. Float stores decimal numbers with less precision, meaning it's fast and memory efficient. Float memory is 4 bytes, 32 bits. Its precision is about 9 digits. Best used for quick calculation and basic measurements. Just don't forget the F at the end. Next is double. Double is more precise than float, good for big calculations. Double memory is 8 bytes, 64 bits, and its precision is about 17 digits. Best use for general-purpose math and scientific data. Next is decimal. Decimal stores high-precision decimal numbers, ideal for money or banking logic. Decimal memory is 16 bytes, 128 bits. Its precision is about 29 digits. Best use for currency, prices, financial computations. Next is char. Char represents a single character, uses single quotes. Char fixed size is 2 bytes. This is because it uses UTF-16 encoding. Char can't hold more than one character. Next is string. String represents a sequence of characters, text, uses double quotes. String variable size can hold 0 to millions of characters. Strings are immutable, meaning it can't be changed once created. Next is bool. Bool is short for Boolean, and it represents only 2 possible values, true or false. Bool takes up 1 byte in memory. Best used for decision-making, conditions, and logical expressions, like in if, while, or comparison. Next is byte. Byte is a small unsigned integer, no negative values. Byte takes up only one byte, 8 bits, with range from 0 to 255. Best used for raw data, color values, binary files, or small counters. And lastly is long. Long stands for long integer, for very large whole numbers. Use it when numbers get massive. Long takes up 8 bytes, 64 bits, range of -9 quintillion to +9 quintillion. Best use if int isn't big enough, like ticks, timestamps, high score tracking. Each type has a purpose, so always match your data to the right container. That is all for the introduction of C# data types. Operators are how we calculate, assign, compare, and decide. They allow us to add, check conditions, update variables, and control logic. Without them, code is just a static list. No math, no logic, no updates. We have 4 types of operators in C#. First is arithmetic operators. This operators is used to perform basic mathematical operations. The symbol plus adds 2 values. In this example, we can see that int a equals 10 and int b equals 3. By adding a and b in the console.writeLine, we can see that the output is 13. The symbol subtract the second value from the first. In this example, we can see that int a equals 10 and int b equals 3. By subtracting a and b in the console.writeLine, we can see that the output is 7. The symbol multiplies 2 values. In this example, we can see that int a equals 10 and int b equals 3. By multiplying a and b in the console.writeLine, we can see that the output, the symbol, divides the first value by the second. In this example, we can see that int a equals 10 and int b equals 3. The symbol multiplies 2 values. In this example, we can see that int a equals 10 and int b equals 3. By multiplying a and b in the console.writeLine, we can see that the output is 30. The symbol divides the first value by the second. In this example, we can see that int a equals 10 and int b equals 3. By multiplying a and b in the console.writeLine, we can see that the output is 3. The symbol, also known as modulus, returns the remainder of a division. In this example, we can see that int a equals 10 and int b equals 3. By finding the remainder a and b in the console.writeLine, we can see that the output is 1. Second is assigned operators, used to assign and update values inside variables. The symbol, also known as assignment, assigns a value. In this example, we can see that int score value is assigned as 100. The symbol adds a value and stores the result. In this example, the score, which is 100, is then added by an assigned 10. The output of score plus 10 is 110 and then be stored in the score variable. The symbol subtracts a value and stores the result. In this example, the score, which is 110, is then subtracted by an assigned 5. The output of score, 5 is 105, and then be stored in the score variable. The symbol multiplies and stores the result. In this example, the score, which is 105, is then multiplied by an assigned 2. The output of score, 2 is 210, and then be stored in the score variable. The symbol divides and stores the result. In this example, the score, which is 210, is then divided by an assigned 2. The output of score, 2 is 105, and then be stored in the score variable. Third is comparison relational operators, used to compare two values. The result is always true or false. The symbol, also known as equals to, checks if value are the same. In this example, the int player level equals 10 and int enemy level equals 12. The code checks if the player level is equal to enemy level. Player level equals to enemy level is false because player level is 10 and enemy level is 12. The symbol, also known as not equal to, checks if values are different. In this example, the int player level equals 10 and int enemy level equals 12. The code checks if the player level is not equal to enemy level. Player level is not equal to enemy level is true because player level is 10 and enemy level is 12. The symbol, also known as greater than, checks if the left is greater than right. In this example, the int player level equals 10 and int enemy level equals 12. The code checks if the player level is greater than enemy level. Player level greater than enemy level is false because player level is less than enemy level. The symbol, also known as less than, checks if left is less than right. In this example, the int player level equals 10 and int enemy level equals 12. The code checks if the player level is less than enemy level. Player level less than enemy level is true because player level is less than enemy level. The symbol, also known as greater than or equal, checks if left is greater or equal. In this example, the int player level equals 10. The code checks if the player level is greater or equals to 10. Player level is greater than or equals to 10 is true because player level is 10. The symbol, also known as less than or equal, checks if left is less or equal. In this example, the int player level equals 10. The code checks if the player level is less than or equal to 5. Player level is less than or equals to 5 is false because player level is 10. And the fourth one is logical operators, used to combine multiple true-false conditions, Booleans. The symbol, also known as AND, returns true if both conditions are true. In this example, bool has key equals true and is door locked equals false. The code checks if has key is true and if is door locked not true. Since both are true, then display door opens. The symbol, also known as OR, returns true if at least one condition is true. In this example, bool has key equals true and is door locked equals false. The code checks if at least has key or is door locked true. Since has key is true, then display you may proceed somehow. The symbol, also known as not, reverses a condition true becomes false and vice versa. In this example, bool is dead equals false. The code checks if the is dead is false, which is true. Since is dead is false, which is true, then display alive true. With that, operators build decision-making power. Want to check multiple things at once? Combine conditions to control flow. That is all for the introduction of C# operators. Hello! My name is Cardi. In Eve, you clap me and never his hit. That is all for the
Subject, Ethan Cross. Status, compromised. Memory fragments erased. Rebellious tendencies detected. Subject classified as a threat to overmind control.
Initiating memory suppression protocol. Ethan Cross must never The man who once led the rebels. Too bad your so-called freedom ended with chains. You inspired hope, Ethan Cross, but in the end, you were just another failed experiment.
Ethan, they tried to erase you, but you fought back. You were part of the rebellion. You are not their pawn.
So that's what happened to me. They wiped my memory. I was part of something bigger. If they thought they erased me, they were wrong. I'll take back everything.